everybody. I'm getting ready to do lesson 6.3 of actually a lecture, 6.3 LV SAT Math Level 1 today. And circles and their equations is what this lesson is. We got 64 points that will be on your tune-up sheet. And then 62 points of note-taking here, so you have a lot of notes to take here, student. Okay, the overview of this lesson. The SAT may also include questions that relate to basic relationships and a circle and its equation in the XY coordinate plane. And circle terms now. Radius of a circle is a segment whose endpoints, this is a radius here, this is your radius, whose endpoints are the center of the circle and a point, this is your center, and then a point on the circumference, right? A point on a circle. The plural of radius is radii. A chord of a circle, this is a chord here, is a segment whose endpoints are points on the circle. The longest chord of a circle is a diameter. The diameter right here is technically a chord which passes through the center of the circle. So a chord that passes through the center of the circle is a diameter. Angles and arcs. So an arc is a curved section of a circle. This would be an arc right here. This is an arc. A diameter divides a circle into two equal arcs. So this would be a diameter here, and then this arc would equal this arc here, over here, which is called a semicircle. An arc smaller than a semicircle is called a minor arc and is named by its endpoints. A major arc is an arc that is greater than a semicircle. An angle whose vertex is at the center, so this is the center, and your vertex is here, this is an angle here, is at the center, and whose sides are radii are called a central angle. So this angle here would be called a central angle here. These are very important notes for you to take for your SAT math. An inscribed angle is an angle whose vertex is on the circle and whose sides intercept an arc of the circle. So let's get an example of that up. The measure of an inscribed angle is equal to 1/2 the measure of its intercepted arc. So here we have an example here. An inscribed angle is an angle whose vertex is on the circle. So this would be an inscribed angle here. This would be an inscribed angle here. The measure of an inscribed angle is equal to 1/2 the measure of the intercepted arc. So we don't have that here necessarily. This would be an inscribed angle here. So this is x degrees over 2 will be the measure of the angle, which is the intercepted arc. And this is x here. So x degrees over 2 would be the measure of this angle here. So the measure of AC, so the measure of angle AC, which is here, equals x. The measure of its inscribed angle ABC, so ABC, will be 1/2 of x. So the measure of this angle here would be 1/2 of this arc here. That would be the measure of this angle here. Okay, so in circle 0, AB equals 3. So AB equals 3 and CD equals 2. CD equals 2. Which of the following statements must be true? In this situation here, we have three statements here. Angle ABC and angle DCB have equal measures. So 2. So ABC, ABC. So this angle here and DCB, DCB, DCB have equal measures. That's one statement. Another statement, segment AB is parallel to segment CD. Do we know that? And then statement 3, 2 times AE equals 3 times CE. So, and then here are our possibilities, 1 and 2, 1 and 3, 1 only, 2 only. So which one of those do you think would be fact? Well, in this situation here, since the inscribed angles BAD and DCB intersect the same arc, BD, they are equal in measure. Also, inscribed angles ABC and CDA intersect the same arc AC, so their measures are also equal. Since triangles AEB and DEC agree on two pairs of angles, they are similar, so the lengths of their corresponding sides have the same ratio. AB over CD equals 3 over 2. Then AE over CE equals 3 over 2. So 2 times AE equals 3 times CE, which makes statement 2 true. This is true here. Have equal measures since they are not corresponding angles of similar triangles. So in that situation here, which makes statement 3 true. This is the actual true statement here of this situation here. Okay, so angle 1 and 2, 3 only, so it would be 3 only. 2 times AE, this 2 times AE equals 3 times CE, 3 times CE here. Because you have this measure here is 3 and this measure here is 2. And so there is your ratio right there. 2 times AE, 2 times AE would equal 3 times CE here, this measure here. Because this is kind of like your ratio of your two triangles here and here. The correct choice would be D, would be 3 only. So this is your correct response for the question about this inscribed two triangles here within a circle. Circle formula. So the distance around a circle is the circumference. The circumference C of a circle depends on its diameter D. So we don't show a diameter here. We show two radiuses here. So C equals pi D or 2 pi R. This is D would be 2 times R would be D. The length L of an arc of a circle is, so this situation here, this is your length of an arc, is a fractional part of the circumference. So the area of a circle is the number of square units in the region it encloses. The area A of a circle depends on its radius. Area equals pi r squared, pi r squared. A sector of a circle is a region bounded by two radii and their intercepted arcs. So this sector here, you have a radius here, and then this is the intercepted arc here, and then the area of the sector here, area S of a sector of a circle is a fractional part of the area of a circle. So A of S equals n over 360 times pi r squared, area of a circle. So it'll be a fraction part of 360 here, which is your circumference is 360 degrees. What fraction of that circle times pi r squared would give you the area of a sector? So the length of an arc AB of circle O is 8 pi. In this situation here, this is 8 pi. What is the number of square units in the area of the shaded region? So we know that the length of the arc AB of circle O is 8 pi. Find the radius of circle O. Length equals 60 degrees over 360. times 2 pi r equals 8 pi. So when we multiply out that, we end up with 120 over 360 times r equals 8. So 1/3 of r would equal 8. So we're going to solve for r in this case. R equals 8 times 3, which is 24. So we did find our radius here, which is 24. Okay, so now that we know that, find the area of the shaded region. So A of S, which is this area here, this sector of this area here, AS, equals 60 over 360 times pi 24r squared. 24 is our radius. So pi r squared, we need to find the area of that, equals pi over 6 times 576. So this becomes 1 over 6 times pi 24 squared is 576, which equals, when we multiply this out, it equals 96 pi. So it would be response D for this area of this sector here. So let's go into a table. Tangents and radii. A radius drawn to the point of contact of a tangent is perpendicular to the tangent at that point. So in this case here, we have, this is a radius, and this tangent here at P. So the radius is perpendicular to this tangent T right here. So radius OP is perpendicular to tangent T. So in this situation here, we have a radius here, and then we have tangents here. And both these are perpendicular to each other here. So AP is perpendicular to OA, OB is perpendicular to BP, and then these are congruent here, and then we have X degrees there. So tangents drawn to a circle from the same exterior point, in this case P. If the measure of angle P is X, then the measure of the central angle AOB is 180 minus X. So this is kind of a rule here to find this, the measure of this angle here. We know if angle P is X, then this equals 180 minus X. If two tangents are drawn to a circle from the same exterior point P, the tangents have the same length, so PA equals PB, and this is marked here by these congruency points. Opposite angles of the quadrilateral that is formed are supplementary. The segment drawn from point P to the center of the circle divides the quadrilateral, this is a quadrilateral here, into two congruent right triangles. So both these are congruent here. This is your hypotenuse here. And then you have a side here. So you have, basically, you have side angle side kind of congruency situation going on there. APB as well as arc AB. So this is a kind of a tip here on problems that you'll see on your SAT math. Go back and watch this video again, or watch the PowerPoint on PowerShell if you want to get watch it again, because there's a lot of information here. Line segments PA and PB are tangent to circle O at points A and B. So it's tangent here at A and B. The measure of angle APB is 60 degrees. If OP equals 14 over pi, so OP here is 14 over pi, what is the length of the minor arc AB? So we need to find the length of this arc right here. Excuse me. Angle AOB measures 180 minus 60 is 120. So this angle measure here is 120. Since OP divides quadrilateral OAPB into two congruent right triangles, it bisects AOB. So we bisect here. These are 60s here. And then this is going to be bisected too. So this is a 30, 60, 90. The side opposite the 30-degree angle in the right triangle is 1/2 the length of the hypotenuse. So OA, in this case OA right here, is 7 over pi. Since the measure of the minor arc AB, there's a lot going on here. AB is 120. Length of AB equals 120 over 360 times 2 pi times 7 pi. So 1/3, this is 1/3 times, and then these cancel. 2 pi over pi. The pi's cancel. 2 times 7 is 14. So 1/3 times 14, that equals 14 over 3. So we grid that in, 14 over 3. So the length, what are we finding here? 1/2 the length of the hypotenuse of OA. Since the measure of the minor arc is AB, the length of AB. So we're trying to find the length of AB here. This length here of this arc is 14 over 3. There's a lot going on here. I suggest you watch the PowerPoint as well on PowerShell, or go back and watch this video again, because there's a lot of information being dumped. Finding areas of shaded regions indirectly. To find an area of a shaded region, you may need to subtract the areas of figures that overlap. So subtraction. We're going to use subtraction now to find area. The radius of each circle is 1 here in this situation here. The radius here is 1. This radius here is 1. If circles O and P touch the sides of the rectangle, and they do here and here and here and here, ABCD only at the lettered points, what is the area of the shaded region? So we need to find the area of the shaded region here only, and then subtract the two circles. So the area of the shaded region is equal to the area of the rectangle minus the sum of the areas of the two circles. So to do that, the width of the rectangle is equal to diameter of the circle, which is 1 plus 1 or 2. So the length here, well, they're calling it the width, is 2 here. So this is 2, because this is 1, and then this is 1. So that equals 2, and then the length here would be 2 plus 2, wouldn't it? And then the length of the rectangle is equal to the sum of the two diameters, which is 2 plus 2. So we have the area. We can find the area now of this rectangle. Okay, everybody. We got this situation here. We have two circles. We're trying to find the area here. The area of the rectangle is length times width. So in this situation here, they're calling this the length, and then this is the width here, is 4 times 2. So the total area of this rectangle would be 8. Now in this situation here, we have a radius here. We have a radius here of 1 and 1, and then 1 and 1. So this radius here would be 1, 2. That's why the width here is 2. So keep that in mind. And the area of each circle is pi r squared. So it's pi l squared. In this case, it would be L here. This is the length here. I guess we're calling this the length. Then we got two circles. So the L in this case would be 1. In this case here, R equals 1. Don't be thrown by this. This will be confusing. So the area of the shaded region would be 8. 4 times 2 minus pi plus pi, because pi r squared would be pi times 1 squared is 1. So each one of these circles, the area of each one of these circles is pi. So it'd be 8 minus 2 pi. That's the situation here. Diameter and chord relationships. If a line is drawn through the center of a circle, here is the center. If a line is drawn through the center and perpendicular to a chord, this is our perpendicularity here of this chord here. This line here is perpendicular to AB, and then these are congruent to each other, and then these arcs are congruent to each other. Perpendicular to a chord, it bisects a chord in its arcs. If segment OK is perpendicular to segment AB. So right here, OK is perpendicular to AB. Then AM equals BM right here. These are congruency marks here. Measure AK, so measure angle AK, which is here. This measure here is equals the measure of BK here. So another situation, if segment AB is congruent to segment CD, then OM, which is here, equals OP. If OM equals OP, then segment AB is congruent to segment CD. So segment AB, which is here, we did a roundy round here to come back to AB is congruent to CD. We found that up here too, didn't we? Congruent chords are the same distance from the center of a circle, and chords are the same distance from the center of a circle are congruent. So if they're equidistant here with these here, and we said that they were, then these chords are equal to each other. Another factoid that will be handy on your SAT. In the figure PQ, segment PQ, this segment here, PQ, is the diameter of the circle here. And then segment AB is parallel to segment PQ. AB is parallel to PQ, and AB is congruent to CD, The length of chord AB is 3/4 of the length of the diameter. So this is 3/4 of this here. If R represents the radius length of circle O, if R represents that, what is the distance between chords AB and CD? So what is this distance here between AB and CD in terms of R? And then here are our choices here. In terms of R, it is given that AB equals 3/4 times 2R. So AB right here is 3/4 times 2R, because if this is 3/4 of the diameter, which equals 3/2R. So draw OH is perpendicular to AB. So OH is perpendicular to AB, because this is a chord here. And extend OH so that it intersects CD. And so we extend OH so it's going to extend over here, CD. Okay, so we have our circle here. Draw radius OA. So we have our radius here, OA. This is your radius, thereby forming a right triangle OHA. So we have a triangle here, OHA, and it is a right triangle because OH is perpendicular to AB. OH is perpendicular to AB. It bisects AB, so AH equals 1/2 times 3/2 R, which equals 3/4 R. So this length here is 3/4 R. Use the Pythagorean theorem to find the length of OH. So we're going to find the length here of OH. Since we know R, we know this, we need to find the length here. So x squared plus 3/4 R squared equals R squared. So R squared. And this becomes x squared plus 9/16 R squared equals R squared. So solving for x squared equals 7/16 R squared. Okay, so we have our circle here, and we have a radius here, we have our different lengths here. And so, now that we have that, the square root of x squared equals 7, same thing as 7 over 16 r squared is what we came up with. So when we take the root of this, square root of that, x equals the square root of 7 over 4r is what that is. So that would be, since segment AB is congruent to segment CD, OH equals OK. So OH equals OK equals the square root of 7 over 4r, and HK, which is this segment here, is 2 times this quantity here, which this cancels here, so HK equals square root of 7 over 2r is what that amounts to, which is this solution right here, number D, for the length of this segment here. That is one way of coming about to that length. Equation of a circle, center radius form. So the set of points xy and xy coordinate plane that lie on a circle whose center is at here. This will be r, HK would be the center of the circle. R is your radius, xy. So is at HK and has a radius of r, which is pictured here. Described by the equation x minus h squared plus y minus k squared equals r squared. There's your equation of a circle whose radius is at the center. Okay, the equation x minus h squared plus y minus k squared equals r squared is referred to as the center radius form of the equation of a circle. If the circle is centered at the origin, then h equals k equals 0, and the equation of the circle simplifies to x squared plus y squared equals r squared. If the center of the circle is at negative 2, 1, and its radius is 5, then the equation of the circle is x minus h squared plus y minus k squared equals r squared. Now we plug in h equals negative 2, and k equals 1 and r equals 5 into this formula here, and it gives us x plus 2 squared plus y minus 1 squared equals 25. The center and radius of a circle can be read directly from the center radius form of its equation. If the equation of a circle is given as x plus 1 squared plus y minus 5 squared equals 64, you know that h equals negative 1 will be the negative of this, and then k equals the negative of 5, which is 5, and r squared equals 8. So the center of the circle is negative 1, 5, negative 1, 5, and the radius would be 8 in that situation. So which equation could represent the circle shown in the graph? So we have our circle here. Which one of these equations represents this circle? That passes through the point 0, negative 1. So 0, negative 1 would be right here. Counting unit boxes, the center of the circle is located at 3, 4. So when x equals 3, y equals negative 4, that would be the center. So the equation of the circle has the form x minus 3 plus y plus 4 squared equals r squared. So what's our radius in this situation? Therefore, you can eliminate b and c. We can throw these out. So to investigate further, the radius is more than 4 units, so r squared would have to equal at least 16, greater than 16. So it would have to be, we threw these out, so it has to be here, plus 3 and minus 4, and then the radius has to be greater than 16. So this is the only choice left, which it could be. Okay, so what is the center and radius of a circle whose equation is this situation here? By completing the square for both x and y, we're going to divide each term of the equation by 3 and then collect terms of the same variable. So when we divide through, we're going to divide through everything by 3. We get x squared minus 4x plus y squared plus 5y equals 23. When you divide through by 3, you can end up in this simplified form here. Complete the square for x and y. So now we have to complete the square here and then complete there. Remember how to do that? So we take 1/2 of b and square it, 1/2 of b and square it. We end up with 9 here and then 4 here. And then we have to add these on the other side too. Don't forget to do that. So now we have x minus 2 squared plus y plus 3 squared equals 36. 13 and 23 be 36. Circle equation now has a center radius form. X minus h squared plus y minus k squared equals r squared. So now with a center at h and k, which would be 2 and then -3, and then the radius will be 6. Okay, and that was 6.3, the lecture for 6.3, SAT Math Level 1. It's an involved lesson. Go back and watch it again, or you can get on PowerShow.com and you search term Rough Math. You'll find it there. If you would like the PowerPoint version, animated PowerPoint version of it, that would be great too. Or go back and watch the video again, take careful notes, and you should be ready for your tune-up. Thank you very much.